Good cup of coffee. Probably my favorite thing in the whole world. Matter of fact, I think the only thing better would be 2 cups of coffee. And therein lies the premise of EtherChannel, where more truly is better. And in this video, we will look at what EtherChannel does, along with how it does what it does. So I just finished talking about spanning tree. I just finished recording some skills on what spanning tree does. And spanning tree protocol is fantastic because without it, we would decimate our whole network. That's the premise of spanning tree, is that redundancy really is good. We want to have redundancy. So if this link goes down, we still have an alternate path to get places, right? But it's kind of like I just watched Avengers: Infinity War, and in this movie, there's this glove where if they get this glove, you have the power where you can just literally snap your fingers and like destroy the whole universe if you wanted to, right? And that's I saw that, I was like, that's kind of like a non-spanning tree network where the first snap of the fingers is the first broadcast that happens, because as soon as you have a broadcast, if there is no spanning tree, the whole network gets decimated because that broadcast cycles the network thousands and thousands of times per second. And that's great. We love that. That's why spanning tree is great. But there's a time where we might look and go, well, maybe I don't want it to block the links. I mean, big picture, these connections right here really represents the bottlenecks in our network, because we've got all these servers and clients and everything that's connected to these switches, right? And they're all trying to reach each other. So these highways are the ones that get the most clogged. So if we've got, let's just say 40 clients and servers or whatever else connected to these, it might be beneficial to us to actually attach redundant cables here. And instead of spanning tree stepping onto the scene like it always does, and it would if we did this, and just say block, 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 right? We say, no. Back off for a moment, spanning tree. I want to bundle these links together into a single connection. And therein lies what EtherChannel does. It allows you to group the connections together into a single connection. And the reason I emphasize that is because from spanning tree's perspective, it is a single connection. It only sees the one, it's called a port channel interface. So if you've got this single connection, we can then load balance our traffic over it and get the benefits of having those interfaces. Now, it's not as good as it sounds. Let me just say, the advertising is a little bit false in the sense that you look and you go, okay, well, if I take a gigabit, let's just say we have gigabit links between our switches, right? And I take my gigabit links and I add a second gigabit link. It's not like I get 2 gigabits and add another one. It's not that good, because they had to figure out a way of doing load balancing that wouldn't impact the speed. And that means they had to use ASICs to do it. So when we're figuring out our redundant connections, first thing to know about EtherChannel is that you will load balance across 2, 4, or 8 maximum connections. You don't want to try and load balance across 3 or 5 or 6, because in binary, in 1 and 0 land, that doesn't make sense. It can't figure that out at the speed of hardware, right? You have to use some software processing to do that. So the load balancing in EtherChannel isn't perfect, but it's better than having the links blocked altogether, right? So that universal symbol of EtherChannel is a circle drawn across those links. And that's what signifies that we are actually grouping these connections into one through a load balanced connection. The main thing I want to talk about in this video is the big picture premise, because the rest of this skill is going to be how to configure it, how to set it up, how to verify that it's all working. But this can be one of the most challenging configurations you do, not because it's really hard. There's just a lot of nuance to it. It's like if or when you get to the point where you're configuring VPNs, virtual private networks, between your sites, they're not hard. There's just a lot of little switches to turn on and off that have to match between both sides. And that's the biggest thing I want to convey is EtherChannel is not hard. It's just something where you have to have a bunch of matching configurations on all the sides. I'm getting a little ahead of myself. So let me talk about the first thing that has to match. When we're talking about EtherChannel, we first have to match whether it's on or not. And you have 3 potential ways of configuring that. So tough because I want to say just 3, but there's more, sort of. So first off, the way that I immediately gravitate to is manual. I want to go into those interfaces and I want to say EtherChannel on, EtherChannel on. And you can do that. They give you the power to go in and just turn it on and it will work. The challenge with doing that is that you could decimate your network. And the reason why is when you group these together, you splice them together, Spanning Tree does see them as one port channel interface. That's literally the name of the interface that gets created when you do this. And Spanning Tree's like, oh, okay, well, I don't see 2 or 4 or 8 individual cables. I just see the one port channel interface. Well, if you misconfigure one side of that connection, but you've hard coded it at on, or maybe down the road, maybe it's all working initially, and then down the road, someone's like, oh, I need to plug my server in right there. Let me just move that port over, right, to another thing. Well, you could cause a loop in your network that Spanning Tree never detects because we just hard coded it to on. So the best practice recommendation is to use one of these negotiation protocols for both sides to detect, is this really on? Is it properly configured on both sides? And then if so, then I'll enable EtherChannel. Otherwise, no, I'm backing down. I'm not doing that. So this may be our tempted way because it's like, oh, that'd be so easy. It's like trunk ports, right? I can just turn it on and then it's done. This is the suggested way because it's a little more stable, more secure. How about that? To prevent misconfiguration in the future. Now, EtherChannel, first thing about the word. It is a Cisco thing. Cisco created EtherChannel. They participated in the RFC standards, blah, 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 blah. But EtherChannel, that word, that term is a Cisco thing. The rest of the world calls them lag interfaces or link aggregation ports. And that it's the same thing when they came out with the protocols that can negotiate the sides of the connection. Cisco has their own, and it's called PAGP. Oh, at least that's how most people say it. PAGP detects Cisco switches and Cisco connections to form an ether channel between both sides if they're properly configured. Well, when the industry caught up with their lag ports, they came out with their own protocol because they, of course, have to be industry standard so we can use, heathen switches down here in our network, non-Cisco switches. Well, that's what LACP does. It does exactly the same thing as PAGP. It's just an industry standard, so we can use it between Cisco switches and non-Cisco switches. And let me actually broaden your mind a little bit, too. We can do this between a switch and a server. Servers support LACP. Servers have multiple interfaces to where I could say, let's go shunk, 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 because there's a lot of traffic going to that server, and I'm going to splice those together using LACP to negotiate that connection. Or, I mean, the servers, you can hard code it on as well. But the way, and this is where, we'll call it phase 1 of the confusion comes in. It's not that you go in when you configure this and say, I want to use PAGP or I want to use LACP, right? You don't do that. You go in and say the mode of this port is active and the mode of this port is passive. And by so choosing those words that you use, the switch knows to use LACP. Or the mode of this side is auto and the mode of this side is desirable, right? So again, you don't type in PAGP, you type in these modes, and by using the correct mode, it figures out which protocol you're going to use. A little confusing, I know. Now, those modes work the same way. I don't know if you've seen the VLAN where I talked about the different trunk modes. If not, you might want to look at that. There's something that Cisco created called the Dynamic Trunking Protocol, or DTP. And what DTP does is detect if one side or the other is using a trunk link. And when I was describing that, I'm going to use the same analogy. That's why I'm bringing it up here. It's kind of like dating. Like if you've got both sides that are passive, right, in the LACP world, you're never going to have a relationship. You have to have somebody who makes the move, who makes the phone call, who says, hey, do you want to be my friend, kind of thing. You have to have an active person in the relationship. Then somebody can be, oh yeah, of course, I want to be your friend. Let's negotiate an ether channel connection over that link, right? So that's how you want to combine it, is both sides, can either be desirable. You can have two desirable sides. Sometimes it just takes longer to form because they're both actively trying to do it. Same thing here. You can have two active sides, but you don't want to have two auto sides, right? You don't want to have two autos because that's kind of a passive mode, but I don't want to say passive because that'll lead you to think, again, same protocol, right? Same. It's just one works only with Cisco switches. So this is the one that just waits for the connection to be negotiated, but will participate. This is the one that actively or aggressively, how about that, negotiates it, and same thing down here. All right, last thing that I'll say, and then we'll get into the configuration in the next video, is why do you say this is so hard? If it's just the protocol, then it seems like it wouldn't be hard. Well, it's kind of like, I'll call it Ether jigsaw, to where you need to have the right channel group, like all these interfaces have to be joined to the same group number, not at least on one side of the connection. It doesn't have to match the other side, but that can lead to confusion as well. You might have port channel 1 over here, and then you might have port channel 5 over here, and okay, you got to keep those straight. You got to make sure it's using the right protocol, so both sides are using either LACP, active passive, or PAGP, desirable and auto, right? And then every single interface in those groups have to have the identical configuration, right? You got to have the same speed and duplex, and usually that's the easy part. They both have to either be a trunk or they have to be an access port. If they're an access port, they have to be in the same VLAN, not in different VLANs. If they're a trunk port, they have to not only be trunking and working that way, but you have to have the same VLAN list between all those interfaces, and they have to have the same. You see where I'm going, right? And by the way, this is the everything that has to be the same, and if it isn't. And again, think about this. I've just got 2, but think of this. If we have 8 interfaces on all of these switches, right? So that's 16 possible places between each one of these switches where something in that list could be wrong. And if it's wrong, it's not like that's your problem. It's just like it's wrong, and the interface drops out of the port channel configuration. So again, it's not hard. Like, oh, this is so. It's just there's so much nuance to it. That if you're a configurator on the fly, where you're like, oh, and then this, which a lot of engineers are, it's going to be challenging. You're going to spend hours like, oh, and then you got to have your template, right? That's the biggest advice I can give you as we get into the configuration. Create your template configuration, and then copy and paste that in on every single one in a clean setup, right? If you have previous configuration, that can interfere. So that's where all of the nuance and the challenge comes in, is figuring those out. So last thing I'll say, and then we'll wrap it up, is this configuration has to be there not only when it starts, but now and forever. And again, if you don't have tight change control in your system, someone down the road could come in and just be like, oh, I just want to modify this interface for, I'll just say something, something I want to do under there. They type it in and bam, the EtherChannel fails. The protocol will detect the misconfiguration, pull that interface out of the bundle, and you've got major issues just because somebody failed to keep that configuration the same now and forever. Cool. All right. You've now seen what EtherChannel does, along with a little bit of how it does what it does. And in the next few videos, we're going to look at the configuration of EtherChannel in our Arizona location, which has those bundled ports connected. For now, I hope this has been informative for you, and I'd like to thank you for viewing.